Okay, so this is test number 14. We'll start from the first question. A part of micrometer screw gauge is shown by the image when their spindle and anvil faces just touch. Zero error of the screw gauge is. Okay, so they have given a sketch of the screw gauge. The circular scale is given and the midline of the linear scale. So this is the circular scale and this is the midline. They are asking for the zero error. When spindle and anvil faces touch, if the micrometer screw gauge is not erroneous, it should this midline and the zero mark of the circular scale should coincide. But if it doesn't, there's a zero error. When you have to calculate the zero error, first thing you have to think about is to determine whether zero error is negative or positive. So to figure that out, think about this midline of the linear scale, and it is pointing toward this mark that is below zero. Below zero means you can think that those should be negative errors. Since it is below zero, it is pointing towards the mark which is below zero. You can say that this shows a negative zero error. Okay, so if zero error is negative, to calculate the zero error, you have to total number of parts in the circular scale, that is 50 minus, this is showing up to 46, 47, 47th mark of the circular scale, times least count. Least count of this should be 0.01 millimeters. So this is how you find the zero error if zero error is negative. Total number of parts in circular scale minus 47, that is the mark that coincides with the midline of the linear scale, times least count. So this should be 50 minus 47, 3 times 0.01, that is 0.03 millimeters. So this is the zero error here in this micrometer screw gauge. Okay, then we have to figure out whether the zero error to be added or subtracted. We previously determined that the zero error is negative. So the zero error is negative. So if the error is negative, that should be added. 0.03 should be added to any measurement taken from this micrometer. So it should be 0.03 millimeters and should be added to the reading. If the error is negative, correction is positive, meaning that it should be added. Third one is the answer. Second question. When a balloon moves with velocity 12 meters per second, a stone is released from it at a height 65 meters. Time required for the stone to reach the ground is. Okay, so there's this balloon. the balloon is should be corrected, like the balloon should be moving upwards, right? Okay. So when the velocity of the balloon is 12 meters per second, a stone is released. Then the height to the balloon they have given as 65 meters. So when a stone is released at this instant, you should know that the stone also has the same velocity as the balloon. So the stone also has the velocity 12 meters per second when it is released at this moment. So then think about only the stone. Then the stone goes up till its velocity becomes 0, then it falls down under gravity. So what they ask is the time required for the system to have this motion. Okay, then the most common way to do a question like this is just apply S equals ut plus half at squared. I'll apply that upwards. This is the origin of the motion of the balloon. So from the origin, displacement is so when it completes the motion, displacement is 65. But if we take positive side to upwards, this displacement is negative. So finally, it has a negative displacement, and the velocity upwards, initial velocity, that is 12 times t plus half. Gravitational acceleration is downwards, so it is negative 10 t squared. So from this equation, you get a quadratic equation. Just simplify the equation and get the answer. Okay, so this is minus 5. Take to the other side, 5t squared. Take to the other side, minus 12t minus 65 equals 0. 5t squared. So I have to factor this one. So this should be 25 times 13. I think 5, yeah. 25t plus 30t minus 65 equals 0. Take 5t out, t minus 5 plus 30, t minus 5 equals 0. 5t plus 13, t minus 5 equals 0. So you have two factors, t minus 5, this one. Then we can say two answers as t equals 5 seconds or t equals minus 1305. The time cannot be negative, so we can reject this answer. So the answer should be 5 seconds. So 5, the stone takes 5 seconds to complete this motion. So the answer should be the third one for the second question. Third question. When a small ball is projected along a smooth inclined plane of 30 degrees to horizontal, acceleration along and downwards the plane is. So we have this inclined plane and the inclination is 30 degrees. So what they ask is acceleration along and downwards, meaning downwards and along this plane. So if you remember this, you can apply like Newton laws and find that as well. But you should know that if the plane is a smooth plane, acceleration should be g sine alpha. You have to remember these equations if you want to save time, right? So along the plane, this is g sine alpha. So here angle is 30 degrees. So g sine 30. So g means 10, sine 30 is half. So this should be 5 meters per square second. Along and downwards. So along and downwards, this is the velocity is positive. Sorry, the acceleration is positive because in real that this acceleration is actually downwards, right? So this is a positive. But if you think about upward direction, this to upwards, this is a minus 5 meters per second per square second. But since this is what they ask is acceleration downwards, so that acceleration downwards is actually the acceleration is downwards. So that acceleration should be a positive value. So you can get fifth at 5 as the answer. You can derive this like g sine alpha thing by just apply f equals ma downwards along the plane. Then you can prove this one. But you should remember that along the plane, the acceleration should be g sine alpha, given that the plane is smooth. You have to remember that. Okay, fourth question. As shown by the image, 3 cubes A, B and C are placed on horizontal smooth floor. So what they ask is the force by A on B and force by B on C. First, I'll just draw the sketch. So you have this A, then B, then C. A, B and C. Then there's a force capital F applied on this system. So this is a smooth plane. It is on a smooth plane. Then the mass is given as 4m0, 2m0, m0. So what they ask is the force by A on B. So to answer this question, you should have a clear understanding of action-reaction forces and how to separate a system, how to correctly isolate a system when you apply an F equals ma. Okay, so what they ask is force by A on B. So by A on B. On B, right? On B to this side. I will say that is on B, that is by A to this side. I will say that force as capital P. Since there must be a force, there must be a reaction force to the other side. If there is a force like by A on B, there must be a force which is the reaction by B on A. So these are P, P. Okay. Then between B and C as well, there's action and reaction forces. I will say that is Q, Q. So what they ask is by B on C. By B on C is this Q, not this Q. They are in magnitude they are the same, but direction is opposite. So what they ask is this Q and this P. They only asking for the magnitude, right? So it doesn't matter whether you find this P or this Q. Okay. Then you have to apply F equals ma. First I'll apply F equals ma to system. System means the whole system. So horizontally applied. When you isolate the whole system, this is the whole system. And think about horizontal forces. These forces becomes action and reaction forces. These are internal to the system, whole system. These forces are internal. So those forces cancels out. The only horizontal force is capital F. Then the mass of the system is m0, 3m0, 7m0 times, let's say, the acceleration of the system as simple A. First, I found the acceleration of the system, which is F over 7m0. Then I apply F equals ma to C only. To C only. So I can find Q. So if you think about, so you have to separate C. Now the system is only C. Only force applied on C is this Q. There's no any other horizontal forces. So the force is Q. So the only force is Q. And the mass is m0. Acceleration is, the whole system has the same acceleration. That is simple A. So instead of simple A, I can substitute F over 7m0, which I found earlier. So this is F over 7m0. M0 cancels, so this becomes F over 7. So Q, now we found that force, F over 7. Okay. Then we have to find this P. To find P, you can apply F equals ma to A only or B and C at once. I think if you apply B and C, consider this to be a one system like B and C. If you consider that, this Q and this Q becomes internal forces, so they cancel off. only horizontal force on B and C system becomes P. So F is equal to P. Mass of this system which is separated is 3m0 times acceleration. Acceleration is same, F over 7m0. So m0 cancels off, so this becomes 3f over 7. So this is the easiest way to find force P. You could apply F equals ma to A only as well. That also is easy, but we can prevent doing like this is one step easier, right? Okay, so the forces should be so A on B, this is by A on B, that is 3f over 7, and by B on C is f over 7. So the answer is third one for the fourth question. Fifth question. The mass 50 kilogram is hanging by a string which goes over a pulley system. A and B pulleys are movable and their masses are 2 kilogram, 3 kilogram. Given that the system remains in equilibrium, the mass m is. So I've drawn the sketch for that. So this is like looks complicated. It's a pulley system. The whole pulley system is attached to this 50 kilogram, which causes 500 Newton weight. So this looks complicated, but if you if you start from the correct position, then this question is not that complicated, right? Okay. So A and B, those pulleys are movable. If you think about this 500 Newton, to 500 Newton, this weight, there are 3 strings attached. So I'll mark the tension of this string as T1, this string as T2, and this string as T3. So since the system is in equilibrium, this mass is in equilibrium. So 500 Newton force is balanced out by T1, T2 and T3. So what they ask is actually is M. So from this one you can create a final equation and get a value for simple M. Right. So first I'll find T1. Think about this pulley. So here this is mg, and this is a smooth pulley, capital A pulley, and that string which goes around should have the same tension. So tension here should be mg to balance out this weight. Then tension here also should be mg. In that case, T1 should be mg. So we found T1. Then we need to find T2. So this is T2. Here T2, same string. That string should have T2 all everywhere. Okay. Then think about equilibrium of A. On A, upwards there is T2. Downwards there is mg downwards. Mg downwards, which is T1 actually. T1. Then there's another T1 downwards. Then there is a weight as well. This pulley has a weight. So that weight is also downwards. So minus 20. This is equal to 0. So T2 minus 2T1 equals 20. T2 minus 2T1 means I can say 2mg equals 20. Then T2 equals 2mg plus 20. So I'm going to build equations in terms of mg for T1, T2 and T3. Okay, then we have to figure out two way to get an equation for T3. So if this is T3 here, here T3, here T3, here also T3. Okay. So T3 is upwards. Now I am applying equations to B, pulley B. Okay, T3 is the force upwards. That T3 is balanced by T2, two T2s downwards, and the weight of pulley B. So T2 plus T2 plus weight of the pulley B. So those are the forces acting on pulley B. So T3 equals, we found T2 actually. That is 2 times T2, I can substitute this T2 here. 2 mg plus 2 times 20 plus 30. So this is 4 mg plus 40 plus 30, 70. So this is T3. Oh, now we found T1, T2 and T3 in terms of mg. Finally, we can apply equations to 50 kilogram weight, this weight. So if you carefully look at that, T1, T2, T3 forces are upwards, and that those forces are balanced by 500. So they should be equal to 500. Then each of these I substitute in this equation. So T1 is mg, T2 is 2 mg plus 20, T3 is 4 mg plus 70, this is equal to 500. So I'll just divide the whole equation by 10 to simplify this. So G is 10, G. Then M, 2M, 3M, 7M plus you have 2, 7, that is 9 equals 50. So take it to the other side, so this becomes 41, 7M. So M is equal 41 over 7 kilograms. That is the mass of that weight. Sorry, the mass of that weight attached to capital A. That's a value for simple M. So the answer should be first one for the fifth question. 6. An F-32 fighter jet flies to north at 400 km per hour. An H-64 Arch helicopter flies to west at 3 km per hour on the same horizontal plane in the sky. So a fighter jet and a helicopter. The direction of velocity of F-32 relative to H-64 that makes with north is. Okay, first I'll mark north, let's say north direction, this direction. This F-32, I'll just take F-32 as capital F. So it is flying relative to Earth, velocity of F-32 is 400 north kilometers per hour. Then the H-64 I'll take as capital A relative to Earth. So that is flying to west. So this is the west direction at 300 kilometers per hour. So what they ask is direction of velocity of F-32. Velocity of F-32 relative to H-64. So what they ask is the direction relative to A, velocity of F-32. So this is the direction that someone on a helicopter would see that jet is moving. Then just put E in between. So this becomes VFE plus VEA. VFE. So change the letters here. So we can put a minus sign here. VAE. So VFE, we know that this is 400 upwards. Just substitute it here with the directions upwards. VAE, substitute 300 with the direction like this. Then we have to, so these are two vectors, then we just have to simplify that. I can change the direction to the opposite direction and make this negative a positive. So 400 upwards, this becomes plus, change the direction. Okay. So these are two velocities we got. Then I'll represent these velocities in like a triangle, so it will be easier to understand. Okay, so 400 upwards, then we have a 300. So another triangle, I mean, let's I'll put that in like a parallelogram. This is actually a rectangle. So 400 upwards, 300. Then the resultant of this should give us the relative velocity, VFA. This is the resultant. Could be something like this. Then complete the rectangle. So this vector is the resultant, which gives us the relative velocity. They are not asking for the relative velocity. What they ask is the direction of the relative velocity. That makes it north. So direction is this alpha, right? With north, it makes an alpha angle. So I can take tan alpha. This is 300. This also should be 300. Opposite divided by adjacent. So 300 divided by 400. 3 over 4. So tan alpha is 3 over 4. So that's the direction. Alpha is equal to tan inverse 3 over 4. But in the options, we don't have this answer. Right? In the options, we don't have alpha as tan inverse. So that answer could be like a different trigonometric ratio. It could be sine or cos, right? So to figure that out, I'll again draw a triangle. So this should be 3 and this should be 4. Opposite side, adjacent side. So this represents the tan alpha, then hypotenuse should be 5, right? If it is 3 and 4, it should be 5. Then let's choose an answer. Like you can take sine alpha from this. Sine alpha is opposite divided by hypotenuse 3 over 5. So do we have sine inverse 3 over 5? Yeah, we do. Sine inverse 3 over 4. 3 over 5. Second answer, right? So alpha is sine inverse 3 over 5. Alpha is sine inverse 3 over 5. They could ask this question in terms of cos as well. Let's say what is cos alpha? Cos alpha is adjacent divided by hypotenuse, so it is 4 over 5. So alpha is in terms of cos inverse 4 over 5. So the same angle, but in terms of cos, that is 4 or cos inverse 4 over 5. We don't have that. In terms of sine, it is 3 over 5. In terms of tan, it is tan 3 over 4. All represent the same angle, but value when we take in different trigonometric ratios, the value is different. That ratio is different, but all represents the same angle. So if you, whenever you encounter something like that, just draw a triangle and find the hypotenuse, and from that triangle you can go for other trigonometric ratios likewise. Second one is the answer. Seventh question. So this is about densities from hydrostatics. 400 cubic centimeter volume of liquid A, with relative density 0.8, volume 400 cubic centimeters, is mixed with 600 cubic centimeter of a liquid with relative density 0.6. Assuming that the volume does not change while mixing, the relative density of the mixture is. So if this creates a homogeneous mixture, when we mix these two, so the volumes just adds up. So 600 plus 400, that becomes 1000 cubic centimeters. And what they ask is relative density of this liquid, the mixture. Okay, also you should know to convert units, grams per cubic centimeter, kilograms per cubic meter, and the relative density. Without knowing those units, then this question is going to be very hard. Okay. So something you know is, the theories you should study these. Numerical value of relative density 0.8. If you put grams per cubic centimeter here, you can get that. It's the same density, but it is a actual density, not relative density. But 0.8, you can take density as 0.8. 0.6 relative density, you can take it as 0.6 grams per cubic centimeter. So the numerical values are the same. Just put grams per cubic centimeter. Okay. So density of the mixture is equal to total mass divided by total volume. So total volume we know that is 1000 cubic centimeter. Right? Then we have to find total mass. Total mass here is, just multiply these two. Think about the units. Per cubic centimeter cancels off. What you get is in grams, mass in grams for this one. So it is 0.8 times 400. So the unit is gram, which means when you multiply these two, you should get a mass. So it is 8 times 40, which is 320 grams for this liquid. Then for this one, just multiply these two. Cubic centimeter cancels off. So 0.6 times 600. So 6 times 60, 360. 6 times 636, 360. Okay, now we found the mass of each liquid. One is 360, other one 320. I'll just add these two to get the total mass of the mixture. 320 plus 360 grams. So this is 680 divided by 1000. The units grams per cubic centimeter. So if you simplify this becomes 0.68 grams per cubic centimeter. 0.68 grams per cubic centimeter. You should know, if you have this as the unit, grams per cubic centimeter, the numerical value here should be the same density as relative density. So the relative density also should be 0.68. So you don't have to divide those densities by 1000 again, right? Density of water. Just take the numerical value, right? So the answer should be the fifth one. Question number 8. an object with mass 0.1 kilogram is pressed by a force 5 Newton against a wall as shown by the image. If the limiting friction coefficient is 0.5, friction on the box is. So you have this wall. This is not a smooth wall. Not a smooth wall. This has friction. So if you press this object with 5 Newton, so the mass is given as 0.1 kilogram. So the weight should be 1 Newton. Just multiply by 10. Weight is 1 Newton. Just mark all the forces acting on this mass 0.1 kilogram. So there's a normal reaction force, capital R, acting on this one. If this is a rough surface, there's a friction acting upwards on this object. So these are all the forces acting here. So what they ask is the value of this F. Now the system is in equilibrium. So for that to happen, what should be the value of friction? That's what they ask. And additionally, they have given limiting friction coefficient. Limiting friction coefficient. Okay. First, I'll find capital R. Just apply force equilibrium to this side. 5 minus R equals 0. So R is 5 Newton. Okay, normal reaction force we found. Then just apply. I'll apply upwards. So upwards, capital F, downwards 1 Newton. This is in equilibrium, so 0. So F is equal to 1 Newton. That is the friction. 1 Newton is the friction. Okay. That is, this friction is enough. So the answer should be second one. But you may be wondering why they have given this 0.5 limiting friction. Right? So if you apply this one, you can calculate that friction by mu R equation. We'll just apply that. So mu is 0.5. R we found as 5. So this is 2.5 Newton. So now we have two values for friction. One value is 2.5 Newton. Other value is 1 Newton. So which friction should we choose? Okay. If you remember that graph, right? Friction graph. So like this is a static condition. From limiting friction, you calculate the friction, the maximum friction that the surface can apply under a given normal reaction force. So here the maximum friction is 2.5 Newton. Doesn't mean the friction applied also should be 2.5. That is just the maximum friction value. But we don't need the maximum friction in order to keep this in equilibrium. We only need 1 Newton of friction to balance out this weight. 1 Newton is enough. We don't need 2.5. 2.5 means up to 2.5, this surface can provide friction, but it does not mean that that friction is the applied friction. We don't need that much friction. That's the maximum friction that could be applied at a limiting case, but the system is not in a limiting condition. It is before that limiting condition. So it is like friction 1 Newton here, then the apply force to balance. Apply force 1 Newton. 1 Newton of friction is enough. We don't have to go for 2.5. So the answer should be 1 Newton. Answer is second one for the 8th question. Question 9. Work required to stand up a horizontal ladder with mass capital M and length capital L vertically is. Alright. So we have a ladder. Its length is capital L and the mass is capital M. So you have to stand up this like this. So the orientation of the it's made vertical. So what they ask is, in order for this to happen, the work required, actually the minimum work required. Okay, so we should know that when you compare these two, what's the difference? Okay, the easiest way to solve this is think about the gravity centers of the ladder in each orientation. So if we consider this to be the P equals 0 level, we can consider that potential energy of the ladder here is 0 at this orientation. I mean, at this arrangement, potential energy is 0. And this one, center of gravity has moved this much of a distance. That should be a L over 2 distance. So for that to happen, required potential energy is mgh. H is L over 2. So from 0 to mg L over 2, the potential energy has increased. So to increase that amount of potential energy, we have to do work. So the work provided should be equal to this increase of potential energy. So this mgl over 2 minus 0, which is mgl over 2. So that is the work required. Second one for the 9th question. 10th question. 1 kilowatt pump ejects water at 5 meters per second after lifting 300 kilogram of water to a height 10 meter within a minute. Efficiency of the pump is. So what they ask is not the power. Power is given. Efficiency of the pump. So this pump lifts 300 kilogram of water to a height 10 meter. Then ejects that amount of water at 5 meters per second. So to eject 300 kilogram of water at this speed, the time it takes is 1 minute, so which is 60 seconds. Okay. So this is the useful work or the power by the motor. So this is what the motor does. That is what we need from the motor. So I'll calculate that. Useful power. Actually, we are going to calculate power. If you want, you can calculate energy as well. But I'll do this in terms of power. So useful power is, so to lift this 10 meters, required energy is mgh. So mass is 300, g10, h is 10 meters. So this is mgh. Then this is given a kinetic energy. So it should be half mv square. Half, mass is 300. Velocity given is 5 square. So this is the total energy for this to happen. Then this happens within a minute. To make this power, I'll divide this whole thing by 60 seconds. 1 minute. Then 60, here you have 5. So this 500 plus 25 times 5, 125, divide by 2, 500 plus 6 to 5. This is 562.5. Sorry, 562.5 watts. This is the useful power. So that is what we need from the motor. This is the useful power. Useful power, right? But the thing is, motor has a power input of 1 kilowatt, which is 1000 watts. But we only need 562 watts in order to do this. So, if you remember, efficiency is equal to what? Useful divided by input. So the useful amount is times 100%. So the useful amount is 562.5 watts. Input is 1000 watts. The remaining energy is dissipated as heat. We don't need heat from a motor. So that is dissipated, right? That energy is wasted. Only we need this much from 1000 watt. The power input is 1000. Then multiply by 100%. This 100 cancels off. Then what you get? Divide this by 10. So you get 56.25%. So this is the efficiency of the motor. Okay. Remaining efficiency, it doesn't have that efficiency. The remaining energy is dissipated. The total power, normally the power to a motor is supplied by the electricity. 1000 watt is supplied by the electricity. But we only need this energy, this power. The remaining power supplied by the electricity is wasted as heat or sound energies. Okay, so the efficiency is not 100%. Efficiency is 56.25. Answer is third one for the 10th question. 11th, that is from rotational motion. Wheel at rest submitted to an angular acceleration 4 radians per square seconds. Angular displacement of it within fifth second. That is important. Not after 5 seconds, it is within fifth second. Okay, we have a wheel at rest. So initial angular velocity is 0. And is given this acceleration 4. Okay. So first you have to understand what fifth second means. Let's say this is t equals 0. Fifth second is between t equals 4 seconds and t equals 5. What they ask is this displacement. The displacement between 5 and 4. These are moments, right? Moments like 5 when it is 5 seconds. This is after 5 seconds. This is after 4 seconds. So within this displacement, within these two moments is the what we call fifth second, right? Okay, I will say it has an angular displacement θ1 after 5 seconds and θ2 after 4 seconds. So what they ask is actually θ1 minus θ2. This is the fifth second, angular displacement at fifth second. So in order to understand this clearly, that's why I'm putting this in a linear representation. If it's like circular, then it is a bit complicated to understand. So I just put that motion in a linear representation. So this is what they ask. Let's sort of find θ1. So I'm applying equations from here to 5. 0 to 5. I think since the initial velocity is 0, I can apply this equation, right? Just to remind you that I'm writing these linear equations. So for all the linear equations, initial velocity is 0, so you don't have to think about this term. So half AD square. So convert this into a rotational motion. So this is theta, half alpha theta is t square. Okay, so I'll apply first for 5 seconds. So that is to calculate theta 1. Alpha is 4, t is 5 squared. So 2 times 25, that is 50 radians. These angles, right? So this is 50 radians, that is theta 1. Then I will calculate theta 2. So for theta 2, time is 4 seconds. Half alpha t square. Half acceleration is 4. Doesn't change, right? Acceleration is 4 radians per square second all the time. Times, now the time is 4. 4 squared. 2 cancels, so 2 times 16, that is 32 radians. So you understand theta 1 is actually 50 radians. Theta 2 is 32 radians. Difference should be the angular displacement within the 5th second. Okay. So the delta theta should be 50 minus 32. 50 minus 30, 20. 18 radian. So it makes 18 radian of angular displacement at the 5th second. Okay, if they say like 4th second, so you have to consider between 4 seconds and 3 seconds. If they say like 100 seconds, 100th second, you have to consider 99 seconds and 100 seconds. The displacement in between. Okay, so answer should be the first one. So next you have a 12th question. It is a sentence question. Let's say A and B, two circular plates with the same thickness, have moment of inertia I1 and I2 around axis through their center, normal to plates. If I1 is greater than I2, consider the sentences below. So the first sentence, mass of A is higher than mass of B. Then radius of A higher than radius B. Both are replaced on top of inclined plane. B reaches rotating to the bottom first. So those are these sentences. I'll just write for I1. Let's say mass of that is M R square. Radius R. Here I'll take mass of M2. Radius R2. So to half, you don't have to think about half. So from this inequality we can get this inequality. So in the first sentence they say mass of A is higher than mass of B. So what they ask is correct one for sure. Can we say that mass of A is higher than mass of B? Just looking at this equilibrium. Can we conclude that? I mean, mass of A, that is M1, could be a small value, but if it is, if R is a large value, R1 is a large value, still this inequality can be satisfied. So we cannot say definitely that mass is larger. Mass could be smaller and radius could be large, very large. Then it's still, so we cannot say mass is large. But we can say that this whole thing is larger, but we cannot single out mass there. So for the B1, radius of A is higher. When we only think about radius, a radius could be a very large value. But if the mass is like very small value, without knowing the mass, anything about the mass, we cannot say that this is the condition. So we have to know about both in order to satisfy this inequality. Okay. This only means these inertias are higher. Mass of moment of inertia of A is higher, but we cannot say individually these terms are higher, like mass only and radius only. We have to like get them together. Okay, then A and B wrong. C, if both release top of inclined plane, B reaches rotating to the bottom first. Since B has a small moment of inertia, this has less inertia. So if you release B from here, this can quickly roll down. B can quickly roll down to the bottom because it has less inertia. Obviously, it has less inertia, it's given, right? So this quickly comes to the bottom. So B takes a small time, then this takes a large time, A takes a large time, B takes a small time. So actually, B reaches the bottom first. So the correct answer should be B only for the 12th question. 13th. Maximum and minimum distances to a comet from the Sun are 1.412 10 to the 12 and 7 times 10 to the 10 meters. When it is at the closest to the Sun, its speed is 6 times 10 to the power 4. Its speed when it is furthest from the Sun is. So a comet, you know the comets, right? So the usually if this is a Sun, comets, they have a tail, right? You don't need that, but it has a tail. So these comets rotate around the Sun. Mostly it is like in an elliptical path with the comet. Maximum and minimum distances. So the maximum distance, they say that is 1.4 10 to the power 12 meters. Minimum distance should be this. This is an elliptical, so that is 7 times 10 to the power 10 meters. That is the minimum distance of the comet. So at these moments, let's say, and the velocity is given, right? When it is closest to the Sun, here, let's say here, comet has this velocity, meters per second. So what they ask is, what is the velocity of the comet when it is furthest from the Sun? Velocity here. For the comet, if you think about a angular momentum, there's no torque acting on the comet, no external torque. It is a free object. So we can say angular momentum of the comet is conserved. Angular momentum. So angular momentum is I omega, right? So let's say here and here, angular momentum should be the same. So I'll say I1 omega 1 equals I2 omega 2. So for I1, I can say mass of the comet times, let's say this radius as R1 squared and omega 1. I2, I'll take it as m, distance is R2 squared. This time I2, right, into R2 squared, omega 2. M cancels off. Same comet, the mass does not change. We have to assume that mass does not change. Then if you put 1r here, r1 times r1 omega is actually v1. I'm going to multiplying this by 1r. R times omega is r omega is tangential velocity. R omega is tangential velocity. So r1 v1 here, r2 times 1, put a 1 r2 here, r2 omega 2 is v2, that is a tangential velocity. Since these velocities are normal at these points, at the furthest point and the closest points in a elliptical, so we can consider these velocities to be tangential velocities. Okay, then you have to just substitute values in order to find v1. Actually, what we need is v1 velocity. Okay, r1 is 1.4 times 10 to the 12. v1 we need. r2 is 7 times 10 to the power 10. v2 given 6 times 10 to the power 4. Divide both sides by 7, 0.2. 0.2. So 0.2 is actually 1 over 5, right? 1 over 5. 0.2 means 1 over 5. 10 to the power 12. v1 equals 10 to the power 10. 4, I'll take that as 10 to the power 14 times this one 6. Cross multiply 5, then this v1 becomes 10 to the power 2 times 30. So 30 times 10 to the power 2, that is 3000. 3000 meters per second. The answer should be the fifth one for the 13th question. 3000 meters per second. Actually, from this one you can understand when it is like further away from the sun, the velocity of the comet is smaller, right? Compare this velocity. This is 6000 meters per second. This is 3000. This is 60,000. This is 3000. Answer should be fifth one for the 13th. 14th question. Change of velocity of a particle moving with uniform speed v in a circular path when it makes 5 over 3 radian is. So you should know that 5 over 3 is equal to 60 degrees, right? 5 is 180 degrees, but if you divide it by 3, it becomes 60 degrees. So there's like a specific way to solve this. If you're just going to like solve this, like trigonometric calculations become like really complicated. So just if you are given a question like this, just follow this method, right? So I'll draw this arc. So this angle is 60 degrees. So this is like part of that circular motion. Velocity here is v. Here is v. So I'll divide this into 30 and 30 degrees. Take this line to be horizontal line, right? Then it will be easier. Take this to be horizontal line. So the magnitude of velocity is same, right? It has a uniform speed. Okay, just extend this velocity like this. So this is 90 degrees, this is 90 degrees. since these are considered to be tangential velocity. 30, 90, then this should be 60 degrees. This also 60 degrees. Okay, then I am going to resolve this velocity and this velocity. Let's say this point is like 1 and this point is like 2. So I'll resolve this onto this, right? Like onto this line, this velocity. So V cos 60. And the component is to this side, right? V cos 60. That is the component of this along this line. Then I am taking a component of the same velocity along this line, which is a normal line to this line. So that should be actually V, we can say V sin 60 or V cos 30. I'll say cos 30. So this component is V cos 60 to this side, V cos 30 to upwards. So these are the components of this V. Then I will resolve this velocity onto this line. V cos 60. You can see its direction is to this side. V cos 60. To normal direction, V sin 60, or it could be V cos 30. Okay, so these are the. I just resolve both velocities. So the velocity components of this one and this one, this velocity and this velocity. Those are the components of this velocity. These are two are the components of this velocity. Okay. Then we have to take, for the ask is difference. So difference of velocity is equal to, let's say, velocity at 2 minus velocity at 1. Velocity at 2 minus velocity at 1. So velocity at 2. So what are the components? This one and this one. Substitute with the directions. Okay, so upwards V cos 30 plus this velocity. V cos 60 towards the center. So this is V velocity at 2 minus velocity at 1. Then you have to consider this component and this component. So what are the components? V cos 30 plus, that is upwards, this one away from the center, V cos 60. Okay. So you have to simplify these two. This one and this one have the same direction. So we can cancel these two. Since there's a minus here. Then what do we end up with? Delta V. V cos 60 towards the center, I mean this component, minus this component. Here, V cos 60 towards the center, you can make this a positive, I mean, you can make this plus and change the direction of this one. V cos 60 towards the center. Since the directions are the same, now you can just add these two. So this is 2V cos 60 towards the center. 2V cos 60. So what is cos 60? It is half. So 2V times half. Half cancels off V. Oh, so this is delta V. This is delta V. Okay. So that's the change of velocity, and you can see direction of the change of velocity is towards the center always. Okay. So direction of velocity is towards the center. So that's how those centripetal acceleration is created. That change of velocity over time, that is acceleration. That acceleration is always towards the center. It is set towards the center because change of velocity, direction of change of velocity in a circular motion is always towards the center. So this is just an example for that. So the answer should be fourth one for the 14th. 15. A particle at the top of a smooth hemisphere is released. Angular displacement theta of particle when the contact of particle with surface of the hemisphere loses. So we have this hemisphere, a smooth hemisphere, and a particle is released from top of it. Released means initial velocity here is 0, but it starts to slip. Then what happens is somewhere here the contact with the surface loses. So it would move like this away from the surface. So at that moment, normal reaction force. So normal reaction force becomes 0 at that moment. Once the contact is lost, normal reaction force becomes 0 because normal reaction force between objects is always due to contact of this object. Whenever there's a contact between two objects, there's normal reaction force. If the contact is lost, what becomes 0 is normal reaction force. So at this point, let's say this angle is theta at that moment. That's what they ask, angle. Okay. So to this point, I will just mark forces applying on this object. So R is 0 at this moment, and there's an mg. So this is a circular motion. I'm going to apply circular motion equations to this moment here. I'll apply F equals ma to this moment. Remember, normally you always have to apply F equals ma towards the center whenever you do in a question of circular motion. So I'm applying towards the center. So this angle theta, mg cos theta. That's a component, right? Towards the center, not mg, towards the center, that is mg cos theta. So this is equal to, that is the only force towards the center. That is the only unbalanced force. Then the mass, I will say acceleration. Acceleration is actually centripetal acceleration. Let's say the velocity at this moment is v. Then I can write centripetal acceleration as v squared over r. V squared over r. So then mn cancels off. I'll put r here. Then this becomes gr cos theta. Now I have a combination. Gr cos theta equals v squared. So this is the velocity that this object has as it loses contact. So this is gr cos theta equals v squared. So in order to find cos theta, we need another equation. Another equation can be gained by using energy conservations. So for energy conservation, I'll say that this level has P equals 0 level. You can take any level, I'll just take this level. So since this is a smooth surface, energy here is equal to energy here. There's no energy loss. Energy at point 1 equals energy at point 2. So energy at point 1, this has, let's say the radius of this r, it has a height r. So the potential energy should be mgr. mgr. Velocity 0. So here there is no kinetic energy, it only has potential energy. So this is the total energy at point 1. Then I write energy at point 2. As the object is here, what's the potential energy? Potential energy is, you have to find this height from this level. What is that height? So the radius is r cos theta. Sorry. Radius r, think about this triangle. R cos theta is the height. So mgr, what's that? Mgr cos theta. Mgr cos theta. Plus, here it has a kinetic energy. So I'll say that as half mv squared. Just get rid of simple m. So gr equals gr cos theta plus v squared over 2. Okay. Then we have an expression for v squared, right? Here. So I'll just substitute that to that v squared. So gr equals gr cos theta plus v squared is gr cos theta divided by 2. So if you want, you can get rid of gr. So this is 1 equals cos theta plus 1 over 2 cos theta. So if you simplify this, cos theta plus half cos theta, 3 over 2 cos theta equals 1. Then cos theta is equal to 2 over 3. Cos theta is equal to 2 over 3. So theta should be what? Cos inverse 2 over 3. So when the angle is cos inverse 2 over 3, the mass loses its contact with the sphere. Okay, so first we applied F equals ma towards the center and get this combination. Then applied energy conservation to get this combination. And just simplify those two equations in order to get cos theta. Okay, so the answer should be third one for the 15th question.